Okay, so we're trying to solidify this process of doing U substitution. So we want to, for whatever problem we're given, we want to match that problem with this general pattern, this general form right here. And then we're going to let u, some new variable u, be the inside. Then we have to relate du to dx, and they're related by g prime. Now, what we do is we're going to replace g of x with u, and g prime of x dx with du to get an integral of u only. What that does, okay, so if we were to do that for this pattern, what we would get, we would replace g of x with u, and g prime of x dx with du. Then we would get an integral of f of u du, which is an integral of some function of u. And hopefully it's much simpler. Hopefully it's much simpler. Now, the next step is that we have to evaluate this integral of u. And if you have chosen what u should be, what expression in x u should be, you've chosen that badly, then often you can't do this stuff. You can't actually integrate, you can't actually do this integral because it hasn't become significantly simpler. All right, so if you can't do this step, go back and try some other function of x for u. But hopefully you've made the integral much simpler, you can do this integral of u. So you are going to get some function capital F, which is going to be an antiderivative of f. Some function of u, which is an antiderivative of f. Now, we're going to replace u with g of x. Remember, u was equal to g of x, so we're going to just now replace the u's with what they actually represent in terms of x. And that will give us, get the answer. Now will give us the final answer to the problem. So if you wanted to write down u substitution symbolically, it would look like this. We were going to look for integrals of this form, f of g of x times g prime of x dx. And the answer will be that we will find an we will change to u's. We'll replace g of x with x, g prime of x dx with du. So then we'll get the integral of f of u du, which is exactly this. We can do this integral, hopefully, and we get some particular antiderivative of capital F, of lowercase f. And then the answer will just be capital F of u plus c. By u, so we will have replaced that with g of x. here f is the antiderivative, or let me just say f prime is going to be lowercase f. The derivative of capital F with respect to u will be lowercase f. So this is u substitution symbolically. Okay, so let's do some examples. Let's start with a non-trivial example. Let's try to integrate x squared times the quantity x cubed plus 1 to the 3/2. We're integrating with respect to x. Now, we clearly have some composite functions going on here. We have x cubed plus 1, and we are raising that to the 3/2 power. So that's the composition of two functions. The function which takes x and sends it to x cubed plus 1, and the function that takes x and sends it to x to the 3/2. So that's a good candidate for doing u substitution. So what would u be? U is going to be, the first thing we're going to try for u is the inner function. So we're going to let u be x cubed plus 1. Now, what does that mean for du? Du is going to be the derivative of x cubed plus 1, that is 3x squared dx. And now notice that the thing which makes this integral hard to do, which is sort of the, or in part, the thing that makes this hard, or makes it appear to be hard, is that we have this multiplication here. But actually we get an x squared from the derivative of the inside. So that is great for us. We always want to see, when we are trying to do substitution, we always want to see the derivative of the inner thing, the derivative of the inside function, appearing outside of the function, so to speak. And the 3 doesn't really matter because we can, or we'll see how to deal with that. Okay, so this, it seems like we're on the right track. We're going to let u be the inner function of this composition, and then du is going to be 3x squared dx. Now we're going to change variables from an integral with respect to x to an integral with respect to u. So in order to do that, we need to replace all the x's with u's, and all the dx's with du's. So I'm going to rearrange this function. So I want to end up with a term which looks like 3x squared dx. And so I have an x squared, but the 3 presents a problem unless I also put in a 1/3. So 3 times 1/3 is 1. So this is really just a rearrangement of the problem that I've been given. And now, the x cubed plus 1 I'm going to replace with u, and the 3x squared dx I'm going to replace with du. And now my problem becomes the integral of u to the 3/2 times 1/3 du. Now this is a much easier integral than the one I started with. The one I started with looked very complicated. Running out of space here. Okay, so to do this antiderivative, I can pull the 1/3, the constant 1/3, outside the integral. And so I have 1/3 times the integral of u to the 3/2 du. And now I can use the power rule. I need to increase the exponent by 1, so instead of 3/2, I'm going to have 5/2, and then I have to divide by 5/2, which is the same as multiplying by the reciprocal, 2/5, plus the constant of integration. And if I want to check this step, what I do is I will differentiate this right side with respect to u, and I'll get 1/3 times 2/5 times 5/2, those cancel, to make the coefficient just 1/3, times u to the 5/2 minus 1, which is going to be 3/2. So I've done that step correctly. And now the last thing I need to do, now that I've had this answer as a function of u, is I want to get an answer which is a function of x. But I know what x is. I've erased it now, but I'm sorry. I know what u is. I've erased it, but we had let u be x cubed plus 1. And so if I simplify these coefficients, I get 2/15. And now I can replace u with x cubed plus 1 to the 5/2 plus a constant of integration. And that is the answer to the problem. If I wanted to check that that works, I would differentiate 2/15 times x cubed plus 1 to the 5/2 plus c with respect to x, and I should get my integrand. So I would basically have to use the general power rule, and I would pull down a 5/2, keep the inside the same, reduce the exponent by 1, and then I'd have to multiply by the derivative of x cubed plus 1. And let's see, so if we do some cancellations here, basically this coefficient is going to be 1/3, and this is going to be 3x squared. So that the 3 and the 1/3 cancel, and I just get x squared times the quantity x cubed plus 1 raised to the 3/2. Which is the integrand that I started with. That's the problem. The integral of this is the exact problem I was given. That means that I've done the problem correctly.